Welcome. In this video, we will be going over the examples for Lesson 18, Module 1 for Grade 7. We're going to talk about scaling, or we'll talk about finding the actual length from the scale image. So for all of these, we'll be given a scale image and we'll be multiplying or dividing by the scale factor in order to bring it up to the actual size. In example 1, Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design shown below. So here's the design of the half-court. After checking with the school administration, he is told that it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. We want to know, will the lot be big enough for the court he planned? So here is the court. We don't care about the lines on the inside. All we know is that in the drawing that Vincent made, it's 2 inches wide and 1 2/3 inches tall. We also know that the scale of the drawing is 1 inch on the drawing corresponds to 15 feet of actual length. So every 1 inch on this drawing is 15 feet. We're going to find the actual dimensions of this drawing, the actual width in feet and the actual height in feet, to see if it will fit on the empty lot that is 25 feet by 75 feet. So these measurements need to fit within that space. Now, in order to do this, we first need to figure out the scale factor. And remember, the scale factor is the scale dimension divided by the actual dimension. Scale factor we're going to define as scale divided by actual. And in this case, we have 1 inch divided by 15 feet. Now we could find however many inches 15 feet is, multiply it by 12, and then we would be able to find the scale factor in inches. But right now it's okay that it's in inches to feet because we want our answer to be in feet, and this what we start with is in inches. So we're going to use the equation scale measurement equals the scale factor times the actual measurement. In this case, for the height, it's 1 2/3 inches. Here's our height. That's our scale measurement. The scale factor is 1 inch over 15 feet, and we want to find our actual height. So 1 2/3 times 15. So remember, if you divide by 1/15, which is how we would solve this one-step equation, that's the same as multiplying by the reciprocal, 15 over 1. So that's why we're multiplying the scale inches by the reciprocal of the scale factor. That'll give us our actual height. And that gives us 25 feet for our actual height. So we know that this is actually 25 feet at its actual size, and that will fit in one direction. Now we need to check the 2 inches to see that if it's less than or equal to 75 feet. So this time our scale dimension here, our scale width is 2 inches. We're still using the scale factor of 1 inch over 15 feet. And we're going to find our actual width this time. Again, we have 2 inches times 15 feet, and our actual width is 30 feet. So this basketball court will fit on the 25 feet by 75 feet school property because it is 25 feet by 30 feet. Both dimensions are less than or equal to what's given there. Okay, let's take a look at example 2. Example 2 we're going to do it the exact same way. But this time we've got a garden, and the scale is 1 centimeter for every 20 meters. Each square in the drawing measures 1 centimeter by 1 centimeter. So we're looking at the garden here. That's this part with the green bushes and the red. I'm not sure what those are. We don't care about the squares around it. This is just the grid that they're putting the picture of the garden on. We know that our scale factor is 1 centimeter for 20 meters. Now we could change 20 meters into centimeters if we wanted to, but it makes sense to measure this garden in meters at the end, so we're not going to do that. The height of this garden is 4 units, which means that it's 4 centimeters. The width of this garden is 8 units, 1, 2, 3, 4, 5, 6, 7, 8. So that means it's 8 centimeters. These are our scale dimensions, our scale height and our scale width. We're going to use the same equation as before. Our scale measurement equals our scale factor times our actual measurement. And here's the math. 4 centimeters equals 1/20th times some actual height. So to solve this equation, 4 times the reciprocal of 1/20th, 20 over 1, will give us our actual height. So our actual height of this garden is 80 meters. It's 80 meters from here to here. And that makes sense. If each of these squares is 20 meters, then it's 20, 40, 60, 80. We're going to do the same thing as the width. We can check and see 20, 40, 60, 80, 100, 120, 140, 160. We should get 160 meters after doing the math. 8 centimeters equals 1 centimeter over 20 meters times our actual width. 8 times 20, I'm multiplying by the reciprocal of this instead of dividing by 120, gives us our actual width. So 160 meters is our actual width. Our last example, we're doing the same thing, only this time we have fractions of inches. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 1/4 or 25 hundredths of an inch on the scale picture corresponds to 1 inch in the actual advertisement. What will be the length and width of the tablet on the advertisement? So here's the scale picture, and this time we're enlarging it. We've got 1/4 of an inch in our scale drawing equals 1 inch in our actual drawing. So before we were making our scale drawing was smaller than our actual object, and in this case as well. And the scale factor is going to be 25 hundredths. I'm going to use that in my equation. Scale measurement equals scale factor times actual measurement. In this case, when we want to find the scale height, 1 1/4 inches equals 25 hundredths of an inch, or 1/4 inch, times the actual height. So if we multiplied our actual height times 1/4, we would get 1 1/4 inches. So we're going to, to solve this, we're going to divide 1 1/4 by 25 hundredths. And that's going to give us 5 inches in actual height. If you wanted to, you could turn 1 1/4 inch into decimals and do this problem that way as well. They don't have to stay in the form they're in. You can convert them between decimals and fractions whenever you want to. For the width is 1 1/8 inches here, and that's going to be equal to 1/25 hundredths of an inch over 1 inch, gives us our actual width. Again, we're going to divide by the scale factor, and we get 4.5 inches, our actual width. So the advertisement needs to be 5 inches tall and 4.5 inches wide. All right, so now we need to make sure that we have everything filled out and bring it to class for homework. See you then.